Well, welcome. This is our presentation today. I am Skylar Bishop. I am with Contino. Contino is a DevOps consulting company out of London, which makes us cool, I hear, because we're, startup and out of London, and that's cool, I hear. I don't agree with that at all, of course. It's not why I work there. So Contino, again, DevOps consultant company. Our mission is basically to take companies and if they don't know how to do simple things as like Agile, we do that. If they don't know how to do pipelines, we teach them pipelines. Basically, it's let's fix all the things that are preventing you from not moving your code out quickly. JP Dienst here, you'll see him in a little bit. He is the mad programmer scientist on the back end of this. He wrote some amazing code for this that does literally nothing. You're right. And then John Leach Pepin, JP's with Black Diamond, John is with One Call. So, part one, why? I don't know if you've ever heard Simon Sinek do any of his talks. Yes, anyone? Show of hands. Yes, Simon Sinek's great. He says to start with why. So we're going to start with why. You'll be very shocked to hear that. I'm going to say something sensational here for a second, right? Data centers are bullshit. You should really stop doing them because they're expensive, they're time consuming, they slow you down. There's lots of reasons why not. Now, if you're a data center company, well, you probably should leave because we got nothing for you right now. But everybody else, pretty much your company is, if you're in a data center, they're literally holding you back. That's not your fault, of course. You're programmers, we're programmers, that's not what we want, but it is a thing. And the reason why is because we're really all bad at it, of course, right? The things that companies are really bad at are data centers, hardware refreshes, deployment cycles, right? Like everybody in here, you probably wouldn't be sitting here if you're like, oh my God, our pipeline is so fast. We have a CI/CD pipeline that deploys in seconds, right? The fact of the matter is a data center is seen as a cost center. What? Hi, Rick. But the reality is that the large cloud providers give you the same types of resiliency, the same types of security. They're usually better than your security team. You probably have 3, they probably have 3,000 or 300 guys. Let's be honest, right? There's a numbers thing that the cloud providers guys have. They give you better response time, availability, and security. Instead, what you should be doing is treating your infrastructure like you do your code, right? Now, what does that mean? It means that we have the full SDLC, which means pull requests, auditing, branching. We have process in the form of pipelines, repeatability. And by the way, repeatability is kind of that thing, right? We talk about modularity, composition, all these types of concepts, right? Let's do that in infrastructure. So tools aren't the answer either, right? But they're part of it. The thing with seeing a problem in the focus of a tool is that you're only looking at a technical problem. And this is actually an organizational problem. The problem is that we have these teams that are siloed, right? So you're like, hey, we have a development team. And the ops team, they kind of deliver some stuff and they give us this stuff. And it never works the first time because they're the ops team, right? Let's be honest, right? So, let's change that. Let's change that paradigm completely. Let's create these cross-functional teams. Let's take an ops guy who can do some development, right? And let's add him into our development team. That was the first time I kind of got the real kind of guts of what this stuff was all about. Was the first time I, as an ops guy, was detailed into a development team. So, tools should be chosen to mimic your desired culture too, right? That's a cool idea. Let's not go out and pick a tool because, well, that's what the company does, right? Let's look at the culture that we want to build inside of our company, which sometimes can be built from the bottom up. Sometimes you got to convince your management, right? Maybe they should be here at this talk. You should send them next year. It'll be great, I promise. But tools enable the processes. They don't create it, right? So tools enable the process, and they should be chosen to mimic the culture you want to build. And you should focus on your business, right? Like if you focus on any other part of that, you can't justify it. You can't go up to a manager and say, here's why we want to change the culture. Here's why we don't want to integrate Jenkins with our pipeline. The things that companies are good at are their lines of business and getting paid, right? They're not good usually at technology, but here's the really secret part of all this. Most companies really should be technology companies right now. Most of them aren't. They should be. They should try to be. Let's say that you're an insurance agency. Well, how do you get to your customers? You get to them through the internet, right? Like we build these beautiful user interfaces. We build these great backends so that we service our customer request in 200 milliseconds or whatever it is, right? Like we have these great low latency delivery schemes and everything like that. Well, guess what? That really kind of makes you a technology company, doesn't it? So we should start acting like technology companies. And the way you do that is by focusing on the business. So how do we do that? Simply, not simply. If it was simple, everybody would do it. People, processes, and technology, pretty much in that order. Start it with people. You have a great squad that really is interested in the types of tools that we're delivering on. You, again, integrate the SDLC. You have these pull requests that are automatically triggering your CI/CD pipelines, right? Your processes. Repeatability gets back into that. Hired developers. Now, this is a crazy idea. Hire a developer with infra-domain knowledge. What does infra-domain knowledge means? Infra-domain knowledge means you have an engineer that understands the concepts of networking. You have an engineer that has system experience, preferably Linux, no offense to the Windows guys, and container knowledge, right? Now, those aren't necessarily easy things to find, but they can be trained up, right? I can take someone and teach them the OSI model. I can teach someone and teach them Red Hat, right? These things can all be taught, but they need at least the basics of it to get through that. Now, this leads into a concept that Google defines as an SRE, Site Reliability Engineer. If you haven't read the SRE book, I strongly suggest it. It's a great read. They also have an SRE handbook that is actually free right now. If you ping any of us after the conference here, we can get you the URL for that. It's just a PDF you can download. It's basically like a how-to guide of how to look at an infrastructure problem and solve it as a programmer. Put people first. Like, this is stuff that we all hear all the time. We hear, like the managers with their PowerPoint or Google Slides presentations, and they say up there and they're like, we're going to put people first. But really, it's about empowerment, right? So like, we take a developer who has this infra-domain knowledge, and we're like, let's push code. And a key part of that empowerment is a relentless pursuit of the most minimal product that we can deliver. So as infra developers, we want to look at this and say, here's what we want to deliver, here's our pipeline, and we're going to focus on that. Don't ever over-engineer it. Don't deliver anything other than MVP. Does anybody, have you heard this at work? I had never heard this at work before. I'd never heard a manager come to me and say, by the way, I really want you to fail. It's going to be great. And then reward them for failing, right? So some of these concepts are things that we can all integrate around us if we create a blameless culture, right? So it's not like, why did our software fail? It's like, what can we learn from it, right? We look at all of the failures as a software product and we say, these are the things that can make us better. Not this made us bad, right? The failure isn't the bad part. The bad part is the fact that we didn't imagine what could have happened. We didn't build a test for that thing that just failed, right? And of course, the SDLC, we've talked about that. Shared language, here's a concept. How many of you guys have talked to an ops guy who had no freaking idea what you were talking about? Or you had no freaking idea what he was talking about? They. I think it was you. It was me, yeah, well, thank you. JP is no longer speaking after me. Yeah, right, thank you, John, appreciate that. So you want to share language between the two. The way that you do that is you talk about the same concepts. You talk in terms of the software development life cycle. Share language. Track metrics. How many of you here use something like Honeycomb or Prometheus? Yeah, 1, 2, okay, cool. Look those up afterwards. You want instrumentation in your code. You want to be able to track metrics that tell you, the average latency of a query, or every time a user downloads this page, it took this long to pull the JS file down. You want all these metrics because you want to be able to look at them from a holistic and a high-level view. Instrument your code, instrument your backend, and then you get all this data that you can actually peruse. So 2 tools that I love, both of them. Prometheus. Honeycomb is a paid product. Charity Majors, if you've ever heard of her, is an amazing thought leader, a great SRE in the industry. Just a fantastic product all around. Use declarative languages. Most of you guys are probably writing imperative code because you have to, right? Let's be honest, right? Like that's most languages are imperative. In the ops world, we write declarative language, mostly because we're not as good as you are of a developer. I'll admit it. But the other piece of that is we don't want to have to worry about how to get from A to B because it could be different on any cloud provider, on any operating system. You know, there's all kinds of differences in there. And honestly, those differences are meaningless. They are distinctions without a difference. For me, I want to be able to write a code that says, do this regardless of what platform it's on because I need this end state. I don't care how to get there, just do it, right? That's a declarative language. So your tools should enable you to focus on delivering to the business. Cohesion and coupling. Now I'm talking stuff you guys know, right? Like you want cohesive modules, right? You don't want to write a module that does 40 different things. You want a module that just does one thing and does it really well. Microservices, right? Same concept in code that we're doing for infrastructure. And again, metrics have to lead that. So now we're just going to show, now I'm going to show you a little bit of code. And I know this is kind of like against the rules because you guys are devs and you're like, oh, I'm just going to go look at your GitHub repo afterwards, right? But here's some Terraform code. So if you've never seen declarative language before, this is Terraform. So it's JSON compliant, sort of, kind of mostly. 0.12 is going to be fully JSON compliant. This is sort of JSON compliant. You run it through a JSON linter, it's going to cough up a furball. It's just not going to be happy. Yeah, right. Exactly. Quoted, you know, is there a quoted resource statement here? No, it's not. Okay, good. So this is Terraform. Terraform basically is a universal language that uses the similar sort of JSON format. And it says, hey, I need to build an X. Do it in this Y format, right? I need to build a Kubernetes cluster. I need to get it into Azure. I don't really know how to do that, but I do know how to create a resource statement, right? So like if any of you guys are Azure, if you know about Azure, so these are, you know, we're creating a resource group. We're creating a storage account, which is not a big deal. We're doing that for a couple of different reasons, mostly the Terraform state. So Terraform goes out and says, hey, what is out there right now in this resource group that we tried to create? Pulls that state down, and then it compares your declared end state to that state that's out there and determines the differences. That's that declarative concept, right? So we've created a public IP, which you'll see here in a bit. Live demos are always dangerous. I hope it works great for you. We created a container registry. Okay, now we got some more stuff that you guys have probably heard of before, right? This is how we store our containers. So we have a full, JP will be going into the second, full pipeline where we create, you know, based on our code and everything like that, some cool containers inside of Azure. Again, all live, all for real. We've got a Kubernetes cluster here that's kind of cool, you know, like that's like modern. All right, we got Kubernetes box checked, right? Like we're a startup, all right. And then just some other stuff with the Kubernetes. Now, some other cool stuff that we're doing in here is we're also creating some Kubernetes namespace. So this is sort of crossing that, you know, cohesion boundary a little bit because this is a provisioning tool. So provisioning tools really shouldn't try to dabble too much into your end state of your application. You really want your provisioning tool, which is, again, in this case, Terraform, to just stand up your infrastructure. You want it to maybe run some integration tests to make sure that the stuff that you deployed is what you expected it to deploy. Hey, did I get a Kubernetes cluster? Yep. Okay, cool. Great, thanks. Right? But we're also creating something called a namespace in here. But we're doing this, which is really cool, with the previously created Kubernetes cluster ID all inside of Terraform. If you notice, these are all interpolated values, right? So I'm not actually filling in any of these values. I'm not passing it as a variable or anything like that. It's just getting all that stuff from the previously created Kubernetes cluster, realizing that there's a dependency between the two, simplifying that dependency loop, and then going and creating it. So with that, I'll give you JP. Oh, John, right, sorry.
And
John.
Wherever you put the other Safari browser.
Safari?
Or whatever, Chrome, whatever you're using. The one that has all the tabs.
There you go.
And microphone?
Right.
Wouldn't want me to not be heard.
There you go. Go ahead.
Okay. It's going to be a quick demo. He's already shown a lot of,
don't have the GitHub one open, so I can't. Your code's in what? In VS Code? Yeah. Okay. He showed that just for the purpose of the demo, just to show how we can do it with Jenkins, just creating an Azure storage account and a resource group. They spin up really fast. They don't cost anything while they're there unless you actually put anything into them. Perfect for a demo. And then it's going to use afterwards a Jenkins file just to actually run the deployment. Which one is this? Files? It runs the deployment. In this case, it puts it into an Azure file storage, which sends you an NFS share, and it runs a quick test to make sure, yes, the resource group exists. Yes, it has, the storage account has, I think I told it, has a file endpoint, a file HTTP endpoint. That's all this one does. And go back to the trigger it. Right now, it's not in Azure, which actually, what did I call it? I called it dummy. Did I call it dummy? It's main. My main, not your main. Sorry. I need to make sure I'm giving it the right info. Sample dummy resource. So yes. So since he was, did you go to show your? Had you shown your stuff? Oh, that's all we have right now in Azure. So there's definitely no other resource group. Tell it to build now. Trigger. Right now it's running, it's got 2 extra Docker files. One is just an Alpine Linux that will run the Terraform code once it pulls up the Kubernetes pod. The other, once that finishes, it pulls up a second Kubernetes pod, simply to run the inspect tests, destroys both the moment they're done, but the state file is stored in Azure, so next time it runs, it will already know where the data is. And this, if you're doing it, there's other options as far as running the hosting, but this, you trigger it with a webhook, Slackbot, whatever your preference is for triggering your builds on merge, whenever, and it will go and run everything, build it for you. Everything gets built, everything gets put out, and you've got your, as he said, declarative pipeline, declarative files, everything is out, everything's ready for people. Which unfortunately takes, 20 seconds wasn't as bad as I thought. And then while it's doing the tests, which needs to inspect, so it needs to pull up a new node. There's a resource group. And there's my storage account. Wrong one, it's this one. It might have been faster putting it all on one pod, because then it wouldn't have to spin up a second pod and wait for it to start. On the other hand, the pods are slightly smaller because you don't have the extra executables, especially because inspect pulls down most of 76 different Ruby packages to be able to run everything. And it found the resource group, says it's running, and then it's running. So JP has a lot fancier stuff to run now.
Thanks. All right. My name is JP Deans. I am a staff software engineer at Black Diamond. This guy got me into kind of the DevOps movement a couple years ago, so I've been enjoying it and doing it ever since. So let's jump back into our presentations here. Or not. Where are you? There we go. All right. So CI/CD in the DevOps world. Basically what I want to do is, this is awesome. We provisioned a lot of infrastructure. We've got a Kubernetes stack ready to be used, but there's no apps running on it. So as software developers, well, we want to write some apps. We want to put it on here, but we want to do it in a similar fashion. We want all of this to be automated code, automatically deployed. We don't want to manually configure into this stuff, but automation is the key here. Okay, so let's quickly review what Skylar and Jonathan set up. So using Terraform, they were able to take a manifest, a Terraform file, which is that declarative syntax they were talking about, and it's basically the desired state of what they want their Kubernetes cluster to be. So what Terraform did is that it compared it to the current environment. So it reached out to Azure. It said, are these resource groups here? Are you what I expect? So once it compared the desired to the actual, it built an execution plan. And with that execution plan, we then deployed it. And what it did is it spun up on Azure, a Kubernetes AKS instance. It registered Azure Container Services, ACS. We then created a Kubernetes deployment with a Jenkins pod on top of that and a Jenkins image inside the Azure Kubernetes service. So that's all great. So now we just need to make sure, like, well, is it actually provisioned correctly? So Jonathan kicked off some inspect tests, and what inspect did is it basically compared the final output now to what he desired. It passed. You saw his build go, so we're ready to rock and roll. All right. So we need to let's put an app on this thing. So we're all software developers. I'm a bit of a dork. I mean, look at me. I like grilling out, so I bought the smart grill a long time ago, and I was like, I bet I can hack this thing. So I completely reverse engineered it and made this over-architected app that can communicate, remote control it. It can set the temperatures. It'll alert me if the grill temp's too high, too low. So I was like, yeah, you know what? I have a whole lot of time to write an app for Code on the Beach, and I hate Hello World apps because it doesn't really prove anything. So I hacked the heck out of this thing, and it's basically like enterprise FizzBuzz, but for foodies. So, all right, so what do we have here? Basically, it's a front-end web app that's it's a React front-end. It's communicating over WebSockets and a REST API to a Node.js backend. So the Node.js, it's really the middle tier, is an API server. It's running Express. And the responsibility of basically the Node app is to communicate with a grill. So if you had one or more grills attached to this thing, we'll just hypothetically, let's just pretend this is a company, the Sick Grills company. We'll call it that because it's a sick grill. So the idea here would be a client would log into this web portal and they can check on the status of their grill. They don't want it burning the house down. Maybe they're going to bed and they're going to smoke a pork butt for 20 hours. So that type of stuff does happen. So that's why I did write this. So anywho, the Node.js app will communicate with a .NET Core emulator. So the idea is here, well, I didn't really want to bring my grill here. Like, it does work, but I figured you guys would appreciate, not having smoke all in the room. So anyway, it's an actual emulator. I reverse engineered the grill protocol. So it basically tricks the API into thinking it's really communicating with a grill, and it works out perfectly because as new versions are released, we update the emulator, and we can run inside the cloud in Azure Kubernetes a full regression suite. We can run an integration suite. We can run unit tests. Everything just works. So this is kind of a high-level overview of the app that we're going to be launching. But that's not the focus. The app's cool, but it's a means to an end. The real focus here is the CI/CD process. Really what our goal was is when we spun up this cluster is we were thinking one of the hardest things as developers is having a CI/CD process that you don't have to constantly maintain. So you build a regression servers, you build integration servers, you constantly have to keep them up to date. You constantly have to install new software as we're going from .NET Core 1.0, we're now 2.1, you gotta go maintain your integration servers. You gotta make sure that they have enough hardware provision to them so that when I'm kicking off my tests, I'm not queuing up the build because it's going through all the integration tests. So we're like, what if we could just streamline all of this, basically dynamically provision an environment to kick off unit tests, clone our production instance, and run a full set of integration and regression tests. So that's what we've done. No, we hope to do. Okay, so we're going to be doing all of this with Kubernetes. There was a Kubernetes talk. I'm not sure if you saw it. It was Jason Gerard. He did an awesome job in light of the projector issue. I'm not going to deep dive into Kubernetes, but I will give you some high-level overview of what we're doing here. So there are some basics in Kubernetes. So you got pods, services, deployments, and stateful sets. So what we're going to mostly be focusing on today are Kubernetes deployments, but it can't hurt to have a basic idea of what's going on. So all this is kind of based on container technologies. If you haven't checked out the container movement, implore you to do it. It's awesome. It's the future. It's the present. Anywho, so pods are a unit of it is the finest grain atomic unit inside Kubernetes. So it's basically an abstraction layer on top of a container. It's got some extra bits installed with it that allow it to have an IP address, and it gets domain name resolution. So services allow Kubernetes to expose that pod to various resources. So maybe you want to expose that to the World Wide Web, or maybe you just want to keep it internally. There's a lot of different types of services, but for the most part, if we want outside access, we create a service. Deployments are the magic. It is a platform abstraction. It's a newer feature in Kubernetes. So the old way was you had to create all these pods and replica sets, and there's a lot of overhead to kind of get an application out there running and scaled. Deployments are a simplification of that. It's an abstraction layer so that you can control everything from replication, getting your app out there, and we'll deep dive into those in a second. Finally, stateful sets are very similar to deployments. However, if you've worked with containers, you know that state inside your container is ephemeral for the life of that container. So as soon as you tear it down, your state's gone. So if you wrote anything onto disk or persisted it into some kind of volume, if you haven't mounted that to some kind of persistent volume, you're going to lose it once you spin the app down. So for Jenkins, that's not a great thing. Jenkins has a lot of XML files and state that it keeps around when you do builds. So we're using a stateful set for Jenkins. That way we can bring it up and down and it doesn't lose track of what's going on. Okay, so things I will not be covering, but are also pertinent. So deeper down into the rabbit hole, you have storage classes, persistent volumes, RBAC security, role binding. We had to do all of that to make this demo work. If you're interested in it, all of this is in the GitHub. We've published it out there, so feel free to go in there, laugh at some of my code. That's fine. But it's important stuff, just not going to cover it today. Okay, so what are the deployment delivery options? This is the fun stuff. So you have if you're a small shop, maybe this is the most basic option. You have halt and update, and that's terrible. Don't do that. You're going to disrupt your clients. Look, we got people grilling. We don't want to shut it down. They need to see the temperature of these grills. All right, we're not doing that. So blue-green releases, these are really cool. You can do all of these with Kubernetes, but this is not just limited to Kubernetes. There's a lot of orchestration tools out there. You have Docker Swarm, Kube, obviously. There's a lot of managed providers, Mesos. You have a lot of options. You can do it with all of these. We're focusing on Kubernetes today because it seems to be all the rage at the conference, or some of the rage. Anyway, blue-green releases. So the idea here is you have two environments. Take a guess, blue and green. So at any point in time, your app is running in one of these environments. So I'm hacking some code, I push up a PR, Skylar approves it, gets merged in. At this point in time, we're gonna then release to the green environment. We're gonna tell Kubernetes to switch over our load balancer reverse proxy from the blue environment to the green environment, and now we seamlessly have our app running on green. Now, like most cases, I wrote some terrible code and I broke the world, right? No good. We can now just tell the load balancer, switch right back, you're back to blue, everything's happy. Canary releases, these are really cool. So if you have to do a lot of possibly A/B testing, maybe you've got beta tests, alpha tests, and you want to release your code to a subset of users, you want to get it out into production, but you don't want the entire world to see it, Canary releases are a fantastic option. Facebook does this a lot with like Messenger and other utilities, but what it'll allow you to do is, let's say we released a new service, we're sunsetting another service, this thing will be replacing it, so we can release this, and in such a way we can have Kubernetes configure it so that maybe 2 or 3% of traffic hits the new service. So it allows us to kind of test this thing without fully exposing it to the world. So awesome for beta tests, really good for A/B testing. So if maybe you have two versions of the same product, you want to see which one gets better feedback, you could do a canary release of both, see which one has better feedback. You'll get a random sample of people hitting each one of those containers. So you can do all of that stuff with load balancing inside Kubernetes. So finally, rolling deployments, this is what we'll be working on. Rolling deployments are effectively a way to mitigate downtime. So it's like a tiered release. So what'll basically happen is when we launch our deployment, we're gonna spin up for each one of our pods or services, we're gonna bring up a new instance, wait till all traffic on the other instance dies down, then we'll bring that guy down and we'll just keep doing that and we'll move on. So basically, bring the new one up, offload traffic from the old to the new, bring the old down. Okay, so Kubernetes deployment, quick deep dive here. So there's both a declarative and imperative form. You can do everything through kubectl, that's the command line utility. We implore you, don't do this. Use the declarative syntax. As Skylar was saying, it's self-documenting. It goes in source control. What you see is always gonna be, your current state is always gonna be what's in the code base, and that is very important. So with Kubernetes deployments, you have a lot of, the release strategies is the means to doing the deployments that we just talked about, the blue-green, canary. So you have strategies where you can do like recreate, rolling updates. That's the means to fulfilling that. Other things that are baked in that just gives you rollbacks, scalability, and audit history. So with a rollback, you could release something and you can automatically call kubectl, roll out, undo, and it'll reverse it back to the last state. So that's kind of how you'd facilitate some of those blue-green deployments. Scalability, through configuration or kubectl with the command line, you can tell it to, you know what, there's a lot of load on this app, spin up some more instances, you can do that pretty quickly. Finally, audit history, this is really important. Depending on what kind of shop you work at, a lot of times like you need a full audit log, you need to see what happened. So it will show you basically every release, the history, why it was released. So really cool built-in tools that are right out of the box. Okay, so this is what the deployment looks like for this emulator app. Really simple here, just some YAML syntax. I won't bore you to death by talking about YAML, but you can see we're basically spinning up one replica for this. So we have a very, very small Azure container, and spinning up a large one for the sake of doing lots of replicas would be expensive, and I don't want to pay for that. So revision history is basically how much audit history do you care about? I'm like, at any point in time, I mean, it's the Grill app, I probably only need to roll back 2 releases. So you have selectors and labels, very much like Docker runs off labels and tags. Kubernetes has a labeling system. This is basically how you can target pods or entities in the cluster. You assign labels to things, and then you query them with labels. So basically, this is, if you guys have seen this, sorry to bore you, but this is kind of the overview. If you're managing, if you're a GUI guy and you like to play around with like the web app, this is pretty much what it looks like. You can see we've just launched a deployment. You can see some CPU, memory usage, other statistics. This is, if I drill into that, you can see all the specifications of, well, it's really hard to read that, apologize. That doesn't matter, but that's just showing you, I'm drilling inside of this deployment. It's giving me all the specifications that you would see inside that audit history. And then finally, all of this can be done on the command line. So if you want to automate it, the fantastic resolution, can't really see that, but that's basically those 2 screens in a command shell version. Okay, so where does this fit into like the DevOps lifecycle? So DevOps, being both dev and ops, it's right there. So right under release and configure is where the CI/CD pipeline is going to fit in. And how do we do it? Well, the takeaway of the day is through automation. Scott Hanselman, most powerful tool we have as a developer is automation, and that's true. We couldn't be doing any of this without automation. That is the key to all this success. Personally, I don't want to do the same thing more than once. I want to write a tool, I want to configure it, automate it, done, and move on to the next fun project. Okay, so let's do a little demo here. Let's see if we can get this thing going. Let's command tilde, all right. So just making sure, so the Sick Grills app is up, it is running. We can turn it on, we can turn it off. Just making sure before I go re-release it. There's our, so it turns on. Grill temperature went back down to 82. It should pop back up. So let's go. Let's torch it. 500. All right. So cool. It all works. That should pop up any second. Wait for it. Yay. Okay. So that's great. So now it's going to pop into Jenkins. But look at that. We've got a broken build, and that's not good. So we're using a live instance, but we clearly have some kind of change that's backlogged that hasn't made its way out. So let's take a look what's going on here. Okay, so we'll scroll into some of the interesting, pertinent parts of this release. I won't bore you to death with all of this text, but what I really wanted to show you guys is that part we were talking about, the regression, automated regression tests, automated integration tests. So what's happening inside this build is we are doing just that. So we have a cluster where we have a number of pods running, and that's the application. During the actual build, we spin up an identical set that's sandboxed from the rest of the world, but is the exact same specifications as what's running in production. We then tag it with an alternative namespace so it can run in parallel with the current production app, and then we run a suite of integration tests across it. So right now I'm using, Postman, fantastic tool. I'm using the command line version of Postman, so I built a container that has Postman in it, and so wrote a series of some environments and collection files, and those collection files will basically call out to the API, and the API will communicate with the backend emulator, and we'll go through a series of tests to make sure our current state and operation is exactly what we expect. So kind of scrolling into this thing, we turned on the grill, we powered it off, did a power toggle, set some grill temp, set the food's probing temp, and then tried to verify what came back from the server, and it looks like 2 tests are not passing. So 2 failed, and what happened is we have some JSON schema that's inside these tests, and they are validating, the specification is validating that the shape of the data coming back is in the exact shape that we expected in, and that's failing. So looks like somebody probably went and changed it and broke it on accident. All right, so let's get back into VS Code. It does not want to switch the hard way. That's exactly what I'm on. Yeah, it was an accidental click. Don't, just come on. Huh. Okay, I'm going to kill that because we don't need it anymore. You're on the main screen. All right. No. Okay. Back in business here. So, oh, there's a nice hint. Yeah, I left that from it. So you can see, see here, we are overriding the isOn property that's coming back from the grill status. So it's been, looks like someone spread this on top of the original result. That was stupid. I'm going to fix that. So we'll just undo that change, redo this change, and let's push it up. Yeah, shh. Don't do a git blame. Oop. Yeah, you're an alias.
Commit message like that. Well, that's as good as a production commit. Fix. Fix again.
So we got a build triggered. It's running. Hopefully, if it fails, I'm just going to finish that whiskey and walk out. But hopefully it'll work. All right, so while this is building, let me kind of dive into what is actually happening here. I don't want to wait on a... Okay, so there's a couple phases in this build. The first phase basically is getting all the source code checkout, really simple, right? Then we want to version and tag that as a specific version. So what we want at the end of the day is a Docker image that's been deployed to our Azure Container Service specifically for this release. So what we're doing is a little hacky hack. I just pulled the git commit ID off of the checkout, and we are going to then build a container and tag it with that as the current version. So once I've done that, and I've built that Docker container image, I need to create a Kubernetes manifest, a deployment manifest specifically to that version of the app. So what we do is basically a little bit of sed magic right now for this demo, replace the current latest tag with the tagged image that we checked out, and Bob's Jungle, we're good to go. So next we want to run some unit tests. So the cool thing about this is there is no software, there's no SDKs, there's no libs installed on Jenkins or on the agents. It's very lightweight, it's doing everything through containers. So the installation of Jenkins is repeatable, it's easy, you don't have to custom configure it, you don't have to keep it up to date with various packages. We literally just do a Docker run, and we are running Mocha and Chai tests against the API server, and we are running some XUnit tests against the .NET Core emulator. So assuming those tests pass, what we want to do next is deploy all those containers up to Azure. So we push them all up with the correct tagged images, and now they are in our realm, and anyone can pull these versions of the app down. So next part is the sweet spot. Doesn't look like a lot because it's just 2 boxes, but it took a long time to do. So this is where we're creating that dynamic deployment. We are parallel running this with the production instance. We deploy it to a separate namespace in Kubernetes so that it's sandboxed, it's isolated. No one outside the environment can touch it, but it can reach out to any resources that it needs. We then kick off all those Postman integration tests against this specific isolated environment, and it runs across basically all the apps, making sure everything's good to go. And if that succeeds, we push it out to production, and we enjoy tasty meats. All right, let's see if the build finished. Hey! All right, so it's good to go. Everything passed. We can go back, take a look at our integration test here. Everything's good to go. Fixie fix worked. So spun up that integration environment, tore it all down so it's not running anymore, and then pushed everything out to production using that phased rollout. That's it. That's all I got.
So this will always be interesting if you're watching this afterwards. There's always that little shuffling noise that happens afterwards, right? So a couple things. I've got some business cards up here if you're interested in contacting myself. We've got, let's see, I think we've got, some references. I'll be posting a link to this on our GitHub readme.md because we're all big Markdown fans. So you'll have both of the two repos that are there. Obviously, I've got my business cards here. There's also some stickers from Contino. We have some really cool ones from different cities that we're in. If you're interested, you're welcome to any of those. And of course, here's our contact information, which if you wanted to take a picture of anything to contact us, this is it. Again, my business card is on the table. Feel free to take any of those. And right now, we'll do any questions. Anyone?
Well, they've all done it already.
They've all done it?
We're too late.
Yeah, we're too late. Any questions on the Terraform piece specifically, right? So what we did here was we spun up an entire Azure environment. We did nothing locally. We did everything as an actual, PaaS. The Kubernetes Pete was a PaaS offering. The container service itself was a PaaS offering. The container registry. Any questions on the Terraform bits? How many of you used Terraform before? Not a one. Awesome. You should, one? Okay, you don't count. I know you. So the interesting thing about Terraform is, again, it's JSON, right? You focus on this declarative end state. The cool thing about it is it starts at absolutely nothing when you run your first Terraform code. You provide it this concept of a provider. If you're doing anything in the cloud, your provider is basically your authentication mechanism. Yes, sir?
Could you point that to a different cloud provider and it would just work?
Well, you could point it to a different Azure subscription and it would work. These, let's go into the a little bit of the Terraform bits if you want to. Did we close it? You jerk. Okay, so if I was showing Terraform bits, what you would see here is that they're all very specific to Azure. Thanks, JP. Great demo. I'll come back next year for sure. So basically, the Terraform bits are very Azure specific. So you create a resource that's an Azure thing, right? So if you've ever done Amazon, anybody, AWS, how many cloud providers have you guys used? Any cloud providers at all? Yeah. So probably AWS or Azure, I'm guessing. You're probably not in GCS, which is Google Compute Services, right? Unless you're really, really heavily into Kubernetes. But if you're in AWS, they have an AKS PaaS offering, platform as a service, AWS. If you're in Azure, it's the same concept. It's called AKS. It's called EKS, I think, over in the Azure or on the AWS, the Amazon side. And they're different resources because they're different beasts, right? So it's the same end state, but it's hey, I'm Amazon. I'm going to call it something different. I'm going to, have all these different parameters. Another interesting thing about Terraform is each of the providers are typically managed by the cloud providers. So the provider, which is the thing that spins up Azure resources, I should really show something else because I'm not actually pointing at Azure, or Terraform code. But when you are creating an Azure resource, that is a provider created by Microsoft, right? So Microsoft manages the Azure cloud provider. Amazon manages the AWS provider. So they have all their unique bits in there that are, making it an AWS versus an Azure concept. It's just different words, right? But the fact of the matter is you have to create different resources. So can you create from one Terraform code something in Azure and then change it to AWS? No. You have to create different resources. Can you move from one Azure subscription to the next? Absolutely. Can you move from one AWS instance to the next? Absolutely. You just change the parameters, change your input variables. It's just like code right at that point. You could write a module that does both. So you could provide it some sort of a switch and say, hey, create this in AWS versus Azure. Yes, question.
So earlier you mentioned there's stateful modules to I guess spin up and down and it keeps track of the log files or whatever.
It keeps a state file where it basically says this is what it deployed, or this
Yeah.
is what it found when it scanned.
So the question.
If you were to change the resource from an AWS to Azure instance, would that statefulness also?
Good
be
question.
there?
The question is, if we were to change the resources in a single Terraform run from an AWS to an Azure resource, what would happen in the state? So Terraform, because it's stateful, it's going to tear down the AWS resources and stand up the Azure resources. The state file says, here's what I did last, and it compares the declared end state to the current state file, or the last state file. And if the things are in the state file but not in the declared end state, it destroys them. Very important thing to understand about Terraform that you usually figure out pretty quickly.
It will destroy it on you.
It will destroy it on you, and it's because it's like, hey, it was in the state file, it's not in my declared end state, you don't want it anymore. I got this for you, like it's trying to help you. Sometimes helpful is bad, right? So yeah, if it's in the state file and not in the declared end state, it will destroy it. But an interesting other thing is, if you, for whatever reason, went into the portal and created something, and then created the resource or didn't create a resource for it, it's not going to touch that, right? It has no idea what's inside of the Azure Resource Manager outside of what you've told it to manage. Yes?
So we at Florida Blue, we use OpenShift, if you've heard of that.
Open what? Shift? OpenShift, sure.
Which is a Red Hat tool. It's a build and deployment tool over Kubernetes. So if all we care about is whether our pod is up and running, and without the infrastructure as a code bit of it that Terraform purports, would you say that this is overkill for companies like that, or well, I guess what are the benefits of Terraform over?
So Terraform is a provisioner, right? So it's the infrastructure components of your delivery pipeline. It could provision OpenShift, right? It could stand up the OpenShift pieces. You can actually, inside of Terraform, create a pod. I don't suggest it, except in cases of things like OpenShift. You really want to create that boundary between your application and your infrastructure. Terraform's great at standing up the infrastructure. You're not going to run Terraform every single time, right? Because if you think about it, we've got these two independent repos. We've got our infrastructure repo and our application repo. Only on the changes to that infrastructure repo are we going to push out changes to our infra. And it might impact things on the back end, right? Like, so it might, if we make a change to the infrastructure, whatever the OpenShift change may be, it might impact existing delivered applications, right? So we only want to run that a few times. And then so like, would I put OpenShift in here? Yes. Would I put anything past that boundary of the infrastructure into the application world? And no. And JP wants to say something.
Yeah, so I'd say like a good example of where you can use Terraform with this is imagine you're running OpenShift on like an east side data center. If you have all of your configuration for OpenShift as declarative syntax in Terraform, it would be as simple as changing one line in Terraform and say run on the west side, Terraform apply, and it would do all the work of configuring OpenShift to basically
Yeah, so what JP was saying there, and I'm saying this for the recording, not for anything else, of course, is that like if you want to move from the east US to the west US, right? So like there's these concepts of regions inside of Azure and AWS and all the cloud providers. If you wanted to move, it's as simple as creating a different variable, right? Like you change your variable from east US to west US. If we hadn't have closed the Terraform code, I could reopen it, take some work. Then I could show you the variables. And basically it's as simple as changing a variable. And then the cool thing is it's gonna go ahead and create that AWS or the AKS instance. It's gonna create a new everything basically inside of this new region. I don't suggest that for disaster recovery because it's kind of a cumbersome process. The reason why we didn't show any kind of a pipeline on the actual Terraform and infrastructure side is because it takes about 20 minutes to spin up an AKS pod. It's closer to 40. Yeah, it creates scale sets, it creates load balancer, it creates all these things on the back end, but those things take time, right? So like basically we created in advance and then just showed you guys the end result of it.
Created the storage account doesn't show.
Yeah, the storage account was the thing that takes the least amount of time to create, basically. So
the point of that is that that change would have gone through a pull request. It's now in source control, and your source control will line up with your end state of your environment. So you've probably wandered into a server somewhere and you found a discrepancy between this server and that. You're like, why is this one different? There's no audit log.
That's probably the benefits of using Terraform, right?
That's where Terraform.
Correct. Yeah, so
don't
the,
know.
the benefits of any declarative end state is I don't worry about where it is. I only tell it what I want it to be, right? And if it's in a different state than that, it's going to fix it. Now, maybe you're like, oh, well, I changed it in the portal. Stop doing that. Don't make changes in the portal. You make changes in the code. Just like, you know, I can't even imagine if you hacked source code by hand and on your Jenkins server and then kicked off a build, like who does that? Everyone. Yeah, changing one variable or whatever, right? Like, so you change your code, you do a pull request, do some sort of push, that triggers your automation, that triggers your deploy. Same concept with infrastructure. You want repeatable infrastructure, right? You've got, let's say, 10 environments. Please don't have 10 environments. You've got 10 environments of your different infrastructure pieces, so you can run it through your QA process or whatever it is. Again, please don't have 10 environments, I beg of you. But let's say that you do. You want each of those to be exactly the same as the environment before, right? You want your code to run the same way in each environment as it does in the first one. And so with Terraform, you create a workspace that's identical across all of your infrastructure. So just to give you an idea, when we create an Amazon, when we create an Azure AKS, Amazon Kubernetes Service instance, this is all the stuff it creates behind the scenes, right? So it creates an availability service, agent pools, agents. It's a ridiculous NIX. You know, we've got like all this stuff. This is all abstracted from us. We said, spin up a Kubernetes service. Done. Right? I don't have to worry about any of this stuff. You know, like it's got a state. I actually did create that. So this is how we share our Terraform state. Because to your question earlier, right? If you think about a state file, what if John over here or JP runs a different instantiation of that Terraform state, right? And then I run it. I don't know about his state. I'm going to destroy all this stuff, right? So we have a shared state file basically inside of Azure so that all of us can run Terraform at the same time and not worry about destroying, because we had that happen.
It did happen.
Yeah, it literally happened. Yeah. 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 And so if you look at the code in our registry, you can see how we handle all it. Yes.
I was actually kind of interested in the inspect tests that for the post.
Yeah. What about?
I was just curious, what are the actual tests look like?
So the question is about inspect tests.
Can you pull up the?
You can.
You want me to pull stuff up on the Mac? Yeah. I haven't had to use a Mac in 8 years, so I don't.
Verifying your
Yeah.
Terraform
It
result is-
inspec is basically server spec, but it can touch SSH and WinRM depending on your system. But the bigger benefit with inspec is, well, in the 2.0 version, which last I checked you have to pull down separately. Or I'll actually pull down the full one because it's a bit more complete. In your control file, you tell it what type of resource you want to hit, and it just uses, in this case, the Azure API to find the object and look at the JSON properties you get when you query the API.
So it is using the Azure.
Yeah. And if you actually look at the results, it will complain, don't use Azure generic resource because it's deprecated because they get inconsistent results. But the only things they provide you are virtual machines, managed disks, and NICs. Actually, they've started adding more, but it's one of those. So what if you want to look at NSGs, but they don't have NSGs? Oh, you have to write your own version of the resource to look at NSGs and get all their properties, because we've deprecated the underlying resource that you're supposed to use to get that info to begin with. It saves time for looking stuff up.
Any other questions?
I think people want to get to the bar.
Yep. So thank you all.